Hello everyone. In the last video, I have given the introduction and basic understanding of the decision tree. And in this video, we will see how to build a decision tree. We will see the mathematical way to build the decision tree. We have two ways of building a decision tree. One is entropy plus information gain, and second is Gini impurity plus weighted Gini. The Gini impurity and weighted Gini, this we will learn in the skitlearn. The skitlearn library uses this method. And the first method, the entropy and information gain, is used by ID3. Okay, we will have a look, we will understand both the entropy and Gini impurity. In this video, I will give you the deep understanding of entropy and information gain only. What is an entropy? Entropy measures the impurity or the uncertainty in the data. It checks the impurity of the node, checks the impurity of the data. And what is the formula for the entropy is entropy of S is equal to minus summation I is equal to 1 to n probability of I log to the base 2 probability of I. S is the data set, the complete data set. It will check the impurity of the complete data set. And Pi is the probability of each class. Each class means, suppose if it is a binary, we have two classes, yes and no. If it is multi-class classification, then it might have 1, 2 and 3. We have 3 classes, or we may have 4 classes. For every class, it will check the probability. That's why it says as probability of each class. And n stands for number of classes. N stands for number of classes. I will solve a binary classification problem. So I will use the entropy of binary classification. What will be the binary classification entropy? See here, minus, if we expand this formula, it will look as minus of probability of S class. Probability of S class into log to the power log to the base 2 of probability of S, plus probability of no class log to the base 2 of probability of no. Okay, we will implement, we will have a better understanding. If entropy value you will get, if you get the entropy value near to 0 or equal to 0, it is equal to 0, then it is a pure data set. That means all the data set has yes values or all the data set has no values. If the entropy is equal to 1, that means it is impure. The impurity is maximum. The error is maximum. Impurity in the data is maximum. That is 50% of yes and 50% of no. That is equal split of data. Equal split of data. Okay. Impurity will be max. So let's have a look. We will consider the same data set. The study hours, attendance. Based on the study hour and attendance, we will predict our target, whether the student will pass or fail. Let's begin the entropy calculation. Step 1, we will count classes. Total, how many we have? We have 5 records, right? We have total 5 records. So our total will be 5. And how many of them are yes? How many of them are yes? 1 and 2. So we have 2 yes. And how many of them are no? We have 3 no's, 1, 2 and 3. So no is 3. Step 2, probability of each class. What will be the probability of yes? That is 2 by 5. And probability of no will be 3 by 5. Okay? 2 by 5 and 3 by 5. And if we put these values, probability of yes and no, in our entropy formula, we will substitute this value and we will calculate the entropy. I will rewrite the formula for you. Entropy of S equal to minus probability of S log base 2 to the probability of S plus probability of no log to probability of no again. Okay. So let's calculate this. Minus probability of S is 2 by 5 log to the base 2 of 2 by 5 plus 3 by 5 log of 3 by 5. You make the calculation, we will get the probability of entropy as 0.97. This is our entropy. Simple calculation. This is our entropy. It is near to 1. That means impure data is near to 1. Is impure data. So now we have calculated the entropy. We have finished the entropy. Now we should go for information gain. We have to calculate the information gain based on the entropy. We will do the information gain. What is information gain? It measures how much a feature means input variable, each input variable reduces the entropy after splitting the data. If we split the data, our entropy is 0.97. If we split the data by using a feature, suppose consider study hours, how much our impurity will decrease. That is the information gain. What amount of entropy will decrease. So the formula for information gain is entropy of parent minus summation of child by parent, weight of, this is child by parent is weight of each child node, into entropy of child node after splitting. That is entropy after splitting. This is entropy before splitting. Entropy before splitting and entropy after splitting, and this value is weight of each child node. This is the formula for information gain. Let's implement this in our example. I will split the data based on the study hours. Here the study hours is greater than or equal to 3. Okay. The left child is no. This is no child. This is left child. And yes, for the study hours greater than or equal to is right child. If it is greater than 3, yes, then it is right child. And if it is less than 3, it is left child. If it is greater than 3, it is right child. So let's make the calculation for left child. We will calculate the information gain. We have to calculate the information gain. So we have to find the entropy of left child. We have to find the entropy of left child. So for this, we have to begin the calculations now. How many yes here? We don't have any S in the data, that is 0. And how many are no? 2 are no. Then what is the probability of S? 0 by 2. What is probability of no? 2 by 2, that is 1, and this is 0. And if we substitute in the entropy formula, entropy is equal to minus of 0 log of 0 plus 1 log of 1. So what is your entropy? Your entropy will be 0. This is the entropy of left child. It is a pure split because it is a pure split. If study hours is less than 3, then the student will fail, definitely fail. There are no chances of passing, there is no pass records. So that's why it is a pure split, and we got the entropy as also 0. Now we have to calculate the entropy of right child. We have to calculate the entropy of right child, where study hours is greater than or equal to 3. We have to calculate the entropy of this right child. Okay. Total, how many records we have? Total we have 3 records. Total we have 3 records. Pass records, yes records are 1 and 2. 2 records. And no are 1. 1 record is no. 1. So probability of yes will be 2 by 3. And probability of no will be 1 by 3. Then entropy of right child will be minus of 2 by 3 log of 2 by 3 plus 1 by 3 log to the base 2 of 1 by 3. If you make this calculation, we will get an entropy of 0.918. Entropy of right child. Okay, this is a impure split because our entropy is near to 1. We got the entropy of right child, we got the entropy of left child. Now let's calculate the information gain. What will be our information gain? See, now what is the formula for information gain? Entropy of parent and entropy of each child, and child by parent, weight of each child node. We have to calculate this as well, right? Weighted child entry. Okay. Now we are making the calculation of this term, child by parent. So total we have 5 records. Total we have 5 records. Left child, how many records we have in left child? 2 records. And right child, we have 3 records. So left child will be 2 by 5 and right child will be 3 by 5. These are our weighted child entropy, weighted child entropy. Now we will calculate the weighted entropy. That is entropy of child. Entropy of child. Entropy of child will be 2 by 5 into entropy of left child. Entropy of left child is 0 plus 3 by 5 into entropy of right child 0.918. So entropy of child is 0.551. This is the entropy of child node. So information gain will be entropy of parent minus entropy of child. Our parent entropy was 0.97 was our parent entropy. So 0.97 minus entropy of child is 0.551. So information gain is equal to, if I make this calculation, 0.420. This is the information gain when we split the data. Study hours is greater than or equal to 3. Okay. Now machine, what will do? Machine won't split the data just on basis of one information gain. Machine will calculate information gain for each feature with different thresholds. I have used here threshold greater than or equal to 3. Now machine will again calculate study hours greater than or equal to 2, study hours greater than or equal to 4, and it will calculate all the information gains. And next it will calculate again for attendance feature. For attendance, it will calculate the information gain greater than or equal for attendance greater than or equal to 70%, attendance equal to greater than 60%. It will calculate all the information gains. Then it will compare the features with different thresholds. Compare the features with different thresholds and select the feature which has highest information gain. This will be the root node to split the data, and it will start splitting the data. And it will repeat again after it makes the first split. Again, it will, suppose at the first split, it has considered the study hours greater than or equal to 3 as the root node. Then at the second split, again, it will consider the attendance data. It will take the attendance feature, it will calculate the information gain, and it will make the further split. So this is how the information gain and entropy works to find the root node and start splitting the data. And at each step, it will calculate the information gain and it will split the data continuously until it reaches the leaf node. This is the calculation. You can practice this calculation to have a better understanding. And remember these formulas: information gain and entropy. Thank you all. In next class, in next video, I will do the Gini impurity.